Okay, good morning, students. Welcome back to my class. We have been learning chapter number 7 in our previous class. You have learned about the metallurgy, what metallurgy means really, and of course, the different methods to extract the metals from the ores or minerals, and the difference between ores and minerals also in detail. Also, concentration of the ore. All these were covered in your previous class. Today we are going to learn two more methods in the concentration or enrichment or dressing of the ore. Now let us get into the lesson. Before start today's lesson, let us recall the terms you have learned yesterday. I mean in your previous class. Okay, so you have learned the difference between mineral and ore. What is the clear difference between mineral and ore? And what are the different physical methods to concentrate or dress the ore? In that, you have learned about the first two methods, hand picking method, and second one is hydraulic wash or wash. Today in our class number 2, we are going to learn the third method, third physical method to concentrate the ore. In today's class, we are going to cover these topics. The third one, that is froth flotation, and the fourth one, magnetic separation. And the most important one is activity series of the metals, based on which we can adopt the suitable method to extract the metal. So it is a very important one, activity series. After that, how to extract or obtain the high reactive metals from their ores, then moderate reactive metals from their ores also, to be covered in today's lesson. Okay, students, let us go to the class. Yes, froth flotation method. As I told you, we have to use different methods based on the nature of the ore to concentrate the ore. The ores like sulfide ores are concentrated by the method called froth flotation method. So what is it? Here you see the block diagram of the froth flotation process. The principle behind this froth flotation is how the impurities are separated from the ore. Preferably, the wettiness of the ore and the impurities, this method is adopted. Actually, some are hydrophilic, some are hydrophobic. That means some particles attracted by the water particles, some are not, some are distracted by the water particles, and some particles are attracted by some other reagents like pine oil. So based on this principle, sulfide ores are concentrated in this method. So let us see how they are in froth flotation, how the ore particles and the impurities are separated. Here we see it is a tub-like thing. In this one air pipe is fitted. From this high pressure air is blown into this pipe, and in the tub the fine powdered ore is taken along with the water. It is the ore fine powder, that is pulverized ore is added to the water, and a reagent is added. This reagent is called a pine oil. Pine oil is preferably it wetted by the oil, hence it floats on the top of the foam, because the ore particles wetted by the pine oil, and these ore particles float on the top in the water. whereas the gangue particles are hydrophilic. They attract to the water particles. So ore is attracted to the water particle and impurities are attracted to the water particles, fine particles and water particles. Then what happens here? Now let us see these are the steps. Okay, 1 minute. We are in froth flotation. Let us see a video which depicts the different steps involved in the froth flotation method. You will understand it in very detailed manner if you see the video. Is it audible to you? Okay, something is wrong. It is not audible to you, I think. Let me check what happened. I stop the PPT and check the audio settings here. Okay, students, let us see the video. Some technical problem is there, I think. So what type of ore is separated by using this method is sulfide ores. Particularly sulfide ores are okay, students, 1 minute. The audio is giving some problem. Let me check it once. Okay, I think it is audible now. Let us play the video once again for our better understanding. See the video carefully to understand froth flotation. What does it mean? Let us see. It is about the froth flotation. The ore contains so this method is used to concentrate the sulfide minerals based on the difference between, see, this is, here we can see the ore is ejected to this tub. This is all water mixed up with pine oil. The air is coming with high pressure. A layer of bubbles is formed at the top of the tub. It contains only the ore powder, that is pulverized ore, whereas the gangue, the impurities are settled down at the bottom of the tub. Thus, the impurities and the ore are separated from the ore, raw ore. Okay. Now, let us see the next method, that is magnetic separation method. What is it? Magnetic separation method. So we have completed three methods: hand picking, washing, froth flotation, and now we came to magnetic separation method. So the word magnetic, you know, some particles are attracted by the magnet. They are known as magnetic material. If the ore is a magnetic material, whereas the impurities are non-magnetic, this method is used to dress the ore. Now let us see a small video how the magnet attacks the magnetic material. Students, this is your common experience. You might have played with a magnet. You rolled it in the soil. Then what happens? Iron particles attach to the magnet. Whereas the impurities, the soil is stays at the bottom of the bowl. Here he has taken the sand. Sand is left behind, whereas the ore, the iron filings are attached to the magnet. This is the principle behind this magnetic separation method. Let us see actually what happens here. See a video here. This is all about the magnetic separation method. The ore is pulverized into a fine powder, and it is sent to a conveyor belt. The belt revolves around magnetic drums. So this is the setup. So this is the conveyor belt, revolves around magnetic drums. These two are the magnetic drums. Actually, this is a magnetic drum. What happens when the ore in the form of a powder rolls over the belt? After coming here, what happens? The drum, magnetic drum, attracts the magnetic material, that is the powdered ore, whereas it left behind these impurities. So the impurities are thrown away and collected separately here, whereas the magnetic ore material, that is ore, powdered ore, is revolves up to here, and here it is released. The ore powder is released and collected separately in the bowl separately. So like this, the magnetic ore and impurities are separated. By this way, we dress the ore. Now, let us go to important one, that is extraction of the metals. This is the second stage actually. After finishing this, we are going to one more stage in the metallurgy, that is extraction of the metals. See children, what are the steps involved in it? See, before going to know the extraction of the metals, we have in our first stage of extraction of the metal extraction, we have done that is dressing or concentration of ore. After that, now we have got the pure ore. Impurities are separated. Now we have pure ore. Now it has to be extracted. We have to obtain the metal from this ore. For that, we have different methods based on the nature of the reactivity of the ore, metal involved in the ore. So, based on the reactive nature of the metal in the ore, we have to adopt different methods. For that, we have to know about the activity series. What is it? What is activity series? The metals are arranged in a decreasing order of their reactivity, which is known as the activity series. In this activity series, high reactive metals are at the top, whereas low reactive metals at the bottom, and the metals of medium activity are settled down in the middle of the activity series. Here we see the metals like sodium, potassium, calcium, magnesium, aluminum are known as high reactive. The reaction time, when they are added to the other elements, the reaction takes place in 2 or 3 seconds of time. Whereas these metals like mercury, silver, platinum, iron, they are very less reactive or no reactive metals. Whereas zinc, iron, lead, copper are known as moderate reactive metals. So this is the activity series. Based on this activity series, different methods are adopted to obtain the metal from their ores. Now let us see one by one. First we take this series, that is high reactive metals. The extraction of the metals at the top of the activity series, they are also known as high reactive metals. How the high reactive metals are obtained from their ores? This is the topic now. Now let us see. First of all, these high reactive metals are available in the form of oxides and halides. Remaining these moderate reactive metals and low reactive metals are available in sulfide, sulfates, carbonates, like this. So, first of all, high reactive metals. Now let us see the metals of high reactivity. They are in the form of, I told you, oxides and halides. Maybe like, for example, sodium. Sodium halides means sodium chloride or sodium bromide, magnesium chloride, magnesium bromide, like they available in the form of oxides and halides. Magnesium oxide, sodium oxide, aluminum oxide, or sodium chloride, magnesium chloride, like this. The ores of the high reactive metals are in the form of oxides and halides. Based on this nature, we have to adopt. So what are the options before us? So how these high reactive metals are obtained? We have so many methods. This is a flow diagram suggesting us to adopt the best method to extract the metals. So this is the ore that is in the form of oxide or sulfide, chloride, carbonate, or sulfate. All the metals in the form of ore available in the oxide ore, sulfide ore, a carbonate ore, or sulfate ore. So what happens? We adopt a method. The method may be electrolysis. By electrolysis, or a chemical process, or a displacement, the ore is converted into metal ions. Metal ions. So these metal ions, by gaining of electrons, also known as reduction, they are converted into pure raw ore, raw metal. So this is the flowchart or diagram. Now let us go to extraction of the crude metal from the ore. See what are these. This is what I told you a little bit earlier. Based on the reactivity of the metals, metals are divided into three types: high reactive, medium reactive, and low reactive. Now, the question before us is, what is the best reduction process to obtain the high reactive metals from their ores? Okay, children, pay attention and listen carefully. We are going to learn an important topic actually. So, the simple chemical process is there. With the help of a simple chemical reaction, like heating with coke, that is known as carbon or carbon monoxide, we can reduce the ores. But this is not the feasible method. This is not the feasible one because it requires a huge amount of temperature. Actually, it is not possible, and also it is very expensive. So this method is not suitable to reduce the metal, metal from the ore. So simple chemical reduction methods are not suitable. Then what is there? We can go for electrolysis. But normal electrolysis method, what happens? Instead of the metal deposit on the cathode, the water is formed. That is why it is also not advisable. Then what to do? What is the best method to extract the high reactive metals? The only method is extraction of the metals by the electrolysis, but the ore must be in the form of a liquid, that is in the state of molten state. The fused compounds only electrolyzed state. For example, so we take the sodium chloride ore. First, what happens? What to do? The sodium chloride must be fused. Then only it will undergo the electrolysis. Now let us see what happens. The molten sodium chloride is electrolyzed, then the sodium chloride dissociates into sodium ions, that is sodium cation, and chloride anion. So the sodium chloride is first, we have to convert the sodium chloride into the fused state, that is the molten sodium chloride is used here. That is the main thing in this electrolysis of high reactive ores. What happens in the electrolysis? At cathode, sodium ion, it is the cation, is attracted to the cathode. After attracted to the cathode, it gains 2 electrons. That means the sodium here, the reduction is taking place. Gaining of electrons is known as reduction. Losing of electrons is known as oxidation. All these things you might have learned in 9th class itself. So here, the first step, sodium chloride is disassociated as cation and anion. Sodium, cation, chloride, anion. This normally it is positive charge. Sodium ion is normally it attracted by the cathode. Cathode is a negative charged pole. So this negative charged cathode attracts the positively charged sodium ions. Here what happens at the cathode? Sodium ions gains 2 electrons to form the sodium metal. Then what happens at the anode? At anode, the chloride ions are attracted towards anode. At anode, the chloride ion loses the 2 electrons. Then the chlorine in the form of gas is liberated. Thus, we have extracted the metal sodium. So this is the method adapted to obtain the high reactive metals like sodium. But the condition is the ore must be in the molten state or fused state. But here also one thing is that for this electrolysis, a large quantity of electricity is required to convert the ore into the molten state. So to overcome this problem, suitable impurities are added to the ore to decrease the melting point of the ore. Thus, we can overcome the requirement of huge amount of heat. Now let us see a video which depicts the sodium chloride electrolysis and the formation of the sodium metal. This is the electrolyte. See here how the sodium and chloride ions are formed. Sodium chloride is dissociated into sodium ions and chloride ions. This is anode connected to the positive charge of the battery. This is cathode, a negative pole. So when the current is passed through this electrolyte, see, slowly the sodium ions are attracted by the cathode and the chloride ions are attracted by the anode. Here, the sodium ions are gaining electrons. That means the reduction is done here. The chloride ions oxidizing. They are losing electrons. By this way, the sodium metal is, sodium ore is reduced to the sodium metal. So by the way of reduction, we have obtained the high reactive metals like sodium from their ore. Here, this is the reaction that happens at the anode and cathode. It's very important. There may be a question in your examinations. Write down the equations at cathode and anode in the electrolysis of the sodium chloride. So, students, we come to the end of today's class. So far, in our 2 classes, we have discussed about the various methods involved in the extraction of the metals, various stages. That is, we have completed the first stage, the extraction. That is the concentration of the ore. There are 4 methods. And after that, the extraction of the metals from the pure ore. In that, we have learned about the high extraction of the high reactive metals. Let us try to recall what we have learned in the form of evaluation. Students, try to answer these questions. What are the main stages involved in the extraction of the metals? State the reason for gold and platinum-like metals are available in free state. All ores are minerals, and converse need not be true. You have to justify your answer with a suitable example. Taking a suitable example, you have to justify that all ores are minerals, but all minerals need not be ore. So this is the question, a very important one in the examination point of view also. Now the next question. List any 5 metals that are useful in day-to-day life and also collect the data about their minerals. So this is just like a project, like a question. You have to collect the data about the 5 metals that are used in your life, day-to-day life, maybe in your home or in your agricultural field or some other the fact that is useful to us. Like that. Again, the 5th question is, what is the principle involved in the magnetic separation of the ore? As you know, all the ores are not separated by a single method. There are different methods for different ores. So you have to state the reason. The 6th one is, imagine what would happen if metals are not available in nature. It is a wonderful question. It will test your analyzing power. So try to answer it. What is the best method to extract the high reactive metals from the ores? Just now we have learned about that. We have seen the extraction of the sodium chloride. Okay. Okay, student. With this, we come to the end of the today's session. We'll meet